You've probably seen this scene before. But what if we had spider sense too? Subscribe to AlphaBard Scientist for more scientific explanations. Sounds impossible, but why? Is it because our muscles are too slow? Let's find out. Did you notice something? Your body couldn't react the moment something happened. Your body hesitated, just a tiny bit. That tiny delay is only about 0.2 seconds. It sounds incredibly fast, but in the world of Spider-Man, it's an eternity. So where does that 0.2 seconds actually go? First, your eyes detect what's happening. Imagine someone suddenly throws a punch at your face. Your body doesn't instantly move. Something has to happen first. Actually, 5 different things happen before your muscles even receive the command to move. Can you guess what those 5 things are? What do you think is the slowest part? Your eyes, your muscles, or your nerves? Surprisingly, none of them. In fact, your fastest nerves can carry electrical signals at up to 120 meters per second. That's over 430 kilometers per hour. Fast enough for signals to travel from your brain to your hand in only a few milliseconds. So if your nerves are already that fast, where do the other 190 milliseconds go? The answer is your brain. Before your muscles can move, your brain has to solve 5 different problems. First, vision. Your eyes need to detect that something has changed. But your eyes don't actually see objects. They only detect light. Millions of tiny photoreceptors inside your retina convert light into electrical signals and send them through the optic nerve. At this point, your brain still has absolutely no idea whether it's looking at a dog, a cat, or someone throwing a punch at you. Next, recognition. Those signals arrive at the visual cortex, the part of your brain responsible for vision. This is where your brain starts asking questions. What am I looking at? Is it dangerous? Is it moving toward me? Or is it completely harmless? Believe it or not, this recognition step already takes longer than the electrical signal traveling through your nerves. Step 3, prediction. But recognizing the object still isn't enough. Imagine trying to catch a ball thrown at you. If your brain only reacted to where the ball is, you'd always be too late. Instead, your brain predicts where the ball will be a fraction of a second later. It's constantly making tiny predictions about the future. Without realizing it, you're actually living slightly behind reality. Step 4, decision. Now comes the slowest part, decision making. Should you duck, catch it, block it, or do absolutely nothing? Your brain compares different options, suppresses the wrong movements, chooses the best one, and only then prepares a motor command. In just a fraction of a second, your brain evaluates multiple possible actions and picks the one most likely to keep you safe. Finally, movement. The command travels down your spinal cord, into the motor neurons, and reaches your muscles. Your muscle fibers contract, your arm starts moving, and only then have you officially reacted. All of that, from seeing the danger to moving your muscles, takes roughly 200 milliseconds. So the biggest bottleneck was never your muscles. It wasn't your eyes, and it definitely wasn't your nerves. It was your brain trying to understand what was coming before it could react. In other words, your brain would rather be right than be fast. And that's exactly why humans can't react like Spider-Man with his spider sense. Spider-Man doesn't just react faster. He skips almost everything we just talked about. No waiting, no recognition, no prediction, no decision. His brain already knows danger is coming before his eyes have fully processed it. If humans had that ability, our reaction time wouldn't just improve, it would completely rewrite the rules of how our brains work. What do you think? If you had spider sense, what would you use it for? Let me know in the comments below. And if you enjoyed this scientific explanation, subscribe to AlphaBard Scientist. I'll see you in the next video.
I just wish we could see him. Okay. I just wish we could see Peter.